Okay guys, here we are for video 2. I said I would try and make the last one 4 to 5 minutes and it went 12, so we'll see if I can be more efficient here. Alright, this page is asking you to complete the unit circle with coordinates. Okay, so now in addition to all the angles in degrees and radians, we want x and y coordinates. Alright, so see what you can do with that. You can pause the video now. I'm not going to make a solution, but on the next page you'll be able to look at the answer. So give it a shot, and we'll see what you come up with. So here's the answer, right? All the angles in degrees and radians and the x and y coordinates, and we've also got these kind of indicators that say which trig functions are positive and negative in each quadrant. All right, let's keep going on. So this page has got an example. We want to find the tangent of 240. All right, that's what it asks for. And then the steps are to find the reference angle, to find the ratio, and then consider sine. So in this case, 240, I'm actually going to draw it out. So 180, 240 is here, 240 degrees. That means the reference angle is 60 degrees. Okay, so one way I could do this is draw a right triangle, make that 60, and then fill in what I know. So that means this is 1, this is root 3, this is 2. And so I could say from here, the tan of 60 degrees is equal to root 3. Since we're in quadrant 3, that really means that the x coordinate is negative, the y coordinate here is negative, so the tangent will be positive. So the answer to tan 60 equals root 3 is the same as the answer to the tangent of 40. All right, so we could say, in this case, that's painful to watch, that the tangent of 240 degrees is equal to root 3. All right. Next thing. So, definition of cosine, sine, tangent, cosecant, secant, cotangent using this unit circle. So, it might be hard to see this, but if you know the x and y coordinates at all these points, you can compute the cosine, the sine, the tangent, the cosecant, the secant, and the cotangent using just those values. So it's really, really, really useful to memorize, and you guys will get to the point where you can see something like this, and you'll just be able to kind of quickly reason out what the value is, and that'll be huge for you guys going into junior year. I'm just going to leave this be. Yeah, basically what it's showing is that whatever kind of ratios you have that are computing, in this case, the tangent. So the tangent of this angle is EC over AE. If you continue to keep extending that triangle out, the proportions would be the same. Okay, almost done. Let's fill in this page here. So let's get the blue pen. Cosine 60, so that's going to be, cosine 60 is going to be 1/2. Sine of 5 pi over 6 is also 1/2. Tan of negative 45, so that's down in quadrant 4, right? That's down there. So it's going to be -1. Cosine of pi is -1. Tan of negative pi over 3. Yikes, so negative pi over 3, that's 60. So the tan is root 3 over 1, but it's negative, right? So this is negative root 3. And the sine of negative 270, well, negative 270 is right there. So the sine of that, the opposite over the hypotenuse, is the same thing. So this is 1. This is equal to the sine of 90 degrees. Some discussion questions for you. If the sine of A equals a half, find A. How many answers are there to that? So how many angles have the sine equal to a half? Same thing for cosine. Same thing for tan. So we'll get into this a little bit more next unit, but it's good to think about how many possible answers are there. So I'll stop for a second, let you figure out what you think the answer to that is, and then you can come back and check this video. All right, if you're back, these are actually really easy answers. The answer to all of these questions is infinity. There are an infinite number of angles that solve these. So for example, sine A equals a half. Well, graphically, that means I want to either be here or here, right? Where this angle is 30 or this angle is 30. All right, so 30 is one answer. However, if I rotate one time around and I'm at 390, that's also an answer. Okay, so for this, we could say, well, you got 30 degrees, you got 390 degrees, and you could go forever in positive or negative direction. So tricky, but easy answer, and that's something that we'll get into more next unit. This page is just a repeat of the unit circle, so you don't need that. Inverse trig, yeah. So let's look at this really quick. In these, right, in these equations, so this sine negative 1, this is not the reciprocal, right? This means the inverse of the sine function. So if we take the sine, we normally input an angle and we output a ratio, okay? So with these, our input is a ratio and our output is an angle, all right? So this expression, sine inverse of negative 3 over 2, you could kind of think of that as asking what angle, so the sine of what angle equals negative root 3 over 2, okay? It's really the same thing, and if we solve for x here, x could be, well, let's think about it. We're either here or here, right? We want the sine to be negative, so we're in quadrant 3 or quadrant 4, and we want a steep angle. So this is like, 60 degrees. Its reference angle is 60 degrees. So that means in degrees, x could be either, sorry about that, 240 degrees, or, and I'm going to keep them separate, 300 degrees, all right? And we just talked about on the previous page how you can have an infinite number of answers. So what I'm going to do to both of these is I'm going to add or subtract some multiple of 360. So in other words, if I'm at 240 and I spin around a second time, that's 360 plus 240 degrees, which is 600 degrees. And the sine of 600 is also negative root 3 over 2. All right, so both of these separate parts give you the full answer. So these are called general solutions, right? This gives you all the solutions, all the angles where if you take the sine of this angle, you get negative root 3 over 2. And I should add in here that for k has to be some integer, right? Could be 0, could be positive, could be negative. It's got to be an integer. Second one, solve tan of theta equals root 3. So if tan of theta equals root 3, then really I want some angle where the ratio of the opposite to the adjacent is root 3. All right, that's going to happen, and I'm in radians now. That's going to happen when theta is pi over 6 or 7 pi over 6 ... All right, so the general solution here could be pi over 6 plus or minus pi k. Okay, so here's pi over 6 right here. Sorry guys, I just realized I don't want that to be pi over 6. I want that to be pi over 3. So let's get that right there. Pi over 3. So pi over 3, 4 pi over 3, ... So I need to change this to pi over 3. Okay, I'm still adding the period of pi, but my starting value needs to be pi over 3, not pi over 6. All right, so this is our general solution, right? We want the angles between pi and 3 pi over 2, so that means, this is the border between quadrants 2 and 3. This is the border between quadrants 3 and 4, so we only want an angle in quadrant 3. So in this case, theta is going to equal 4 pi over 3. 4 pi over 3. Okay, that's the only answer. This is called a particular solution, right? Here's a general solution. This is a solution that gives you all the possible angles. When you have one of those or multiple ones, but not an infinite amount, it's called the particular solution. All right, this last one, cosine A equals 0.3, where the angle is between 270 and 360. So for this one, we have to use a calculator. I don't have a calculator on me, okay, but what you would do is you could say, probably should have a calculator on me, right? But you could say that A is equal to the cosine inverse of 0.3. All right, what that will do, if we start with this equation and you have the cosine A equals 0.3, and you take the cosine inverse of both sides, right? And you take here, you take the cosine inverse of that, then these essentially undo each other. They don't totally because of a domain restriction, but it's going to eliminate the cosine, right? And then you would have that A is equal to the cosine inverse of 0.3. Now, this is going to give only one answer, okay? And you have to be sure that your angle is between 270 and 360, so you have to follow the processes before. So I'm not going to fill this in the video because I don't have access to a calculator, but I'll put it in the filled notes so you have the answer there. And that is it, guys. So hope that was useful. Please email your teachers if you have questions. If you're in my class, I'll put up that shared document, and hopefully we'll get more than like 2 responses last time. But again, hope this was useful and hope you guys are doing well. Okay, take care.